Hey you! Yeah you! Isn't breakdancing cool? Well, wanna know how it works? Well, I'll tell you how it works with the power of science! Not just any kind of science, I'm talking about physics! So let me show you how the two worlds collide to make this masterpiece of entertainment. The main aspect of breaking we're going to discuss is the signature power move of breaking called the windmill. The move requires the breaker to propel their legs in the air, preventing contact with the ground. The legs are spread and move around the body in a circular fashion resembling the blades of a windmill. Now that you know what a windmill is, let's look at how physics affects it, starting with friction. Before a breaker is able to move, they want to first overcome the force of friction between their clothes and the floor. Usually, a breaker will only dance on a smooth surface like linoleum. By doing so, the breaker is able to minimize friction and maximize the speed, which is essential because the faster they go, the better the windmill looks. Next, we have Newton's first law of motion. An object at rest shall stay at rest, or an object in motion will stay in motion unless acted upon by an outside force. This is also called the law of inertia. Now, when the windmill is in execution, the legs are moving in a circular fashion, and the legs want to maintain their state of motion, which is a straight path. However, they are attached to the body of the dancer. This crucial connection keeps the legs swinging around without following their tendency to maintain their state of motion. And like previously stated, all this is exemplified by Newton's first law. The windmill also demonstrates centripetal force in its execution. While the legs are moving around the body, there is an acceleration inwards towards the body. This acceleration is that centripetal force. Uniform acceleration is also present in the signature b-boy move. The legs of the breaker act as the radius of the circle, the feet are the points where the velocity vectors are tangent to the circle, and the pivot point of the breaker's body is the center of that circle. Thus, as the dancer executes this move, it is a perfect example of uniform circular motion. Okay, now we've covered the backbone of breaking, now let's check out some more intense moves. Let's take a look at the flare. The flare is like the windmill, except it's more based on balance rather than speed and acceleration. By use of balance and counterbalance, a breaker is able to keep the body and legs from making contact with the floor. Torque is also involved in the flare. The legs can be considered the circle that the breaker is moving within, and the torque is greater at the legs because of this equation. The radius is greater than that of the head and upper body, so the breaker must compensate to balance the torque and move continuously. Last but not least, we have the head spin, a great crowd pleaser. Its physics are about the same as the windmill and flare. It involves circular motion and torque. A skilled breaker is able to have their limbs spread far apart and travel at a fair speed. However, when they tuck in their limbs, they are able to reduce the radius of the circle, and therefore increase their force to maintain the same amount of torque. This gives the effect that the breaker is traveling very slow, then suddenly accelerates their spin just by tucking their limbs in. And that's the physics of breakdancing, ladies and gentlemen. But before I depart, I'm going to show you what it looks like when b-boys incorporate all the moves that I've shown you and more. This has been LeCount Togans. Thanks for watching.